How's it going, everyone? Welcome, Euler Gonzalez here. Today it'll be a very interesting video because we're gonna now explore and dive deep into this thing called concurrency and how do we need to understand about what concurrency is, especially when we are going to now writing JavaScript applications, especially scalable JavaScript applications, and why this is important. So this is a course taught by Kyle Simpson. Shout out to Kyle Simpson. Oh my God, it's like, oh man, if you can donate to him, yes, please, because he's actually jobless. Yeah. But in any case, this is a course that was published almost 8 years ago. God damn. And the idea here is to because we are going to now do as a JavaScript developers, eventually you will need to deal with this way of how you can not only write your applications, understand how your tool works, and by understanding is now how asynchronicity from a conceptual perspective, and then with some exercise, a lot of the time we're going to now build a knowledge in the practical tools to be more strategic and tactical when we need to handle concurrency for async applications. This is something that a lot of the time all of these particular patterns can be used as well as in other programming languages. Again, this is the way of how we do in JavaScript. And for that, we went through first to understand is what is the couple async pattern that we're gonna see. And shout out to Kyle Simpson again. Again, understand what is parallel and async, and then callbacks, and then thunks, and then promise, and generators, and code routine. Something that I think this is widely used also in programming language like Go. Correct me if I'm wrong. The event reactive, aka observables, and how the thing actually works behind the scenes. So for example, you have now Redux as a way to get yourself familiar with, and something called a channel oriented concurrency, which is CSP. Not sure, channel oriented concurrency, which is quite interesting, right? Fuzzy channel-based concurrency runtimes, communication sequential process, channels. This is now from Threads, Java, and Go. It is like piping connecting two processes that flow through that channel in one direction. Interesting. Concurrency multiprocessing and Python's goal. Python's global interpreter. So in JavaScript. CSP and actor model for concurrency. Advanced async. This is how old is this? Oh, look at you, big boy. Look at you. That was 8 years ago. Oh my God. That was 8 years ago. You gotta be kidding me, bro. You gotta be kidding me, bro. Holy crap. Yeah, son. Okay, I don't know how that ends, especially with the CSP, if the community actually moved toward there with CSP. By teaching computer science fundamentals and modern web language like JavaScript, we prepare students to join top flight engineering teams. Mm-hmm. Market square. Oh, is it still together? It's still here? Interesting. Oh, but it's not active. Yeah, it's like it's not active. What the French does this? Someone actually took that and all right. So yeah, it's not active. It's not active. Actually, it died a lot of time ago. Mm-hmm. Okay. Mm-hmm. Interesting. Yeah. Mm-hmm. Um. Okay. Mm-hmm. That's interesting. That's very, very interesting. That's very, very interesting. Um. Again, exactly. It's like they were in, and that's why this is like still there. It couldn't move on there. It couldn't move on here. Mm-hmm. Mm-hmm. Again. This is good. Exactly. It's like people trying to understand that. Exactly. I think. Okay. Yeah, this is more like people try to understand this. This is how you communicate directly with the event loop and how all of these different phases mean. Run timer immediate in run task timer immediate next state micro task. Okay. Exactly, and they're working with workers, right? A message channel and all that kind of thing. All right, cool. Awesome. So, that's quite interesting. So this CSP thing is like they don't actually CSP JavaScript here because he talk about content security policy, but it's not like that. It's async. DSCSP channel for JavaScript like closure script, core async, or Go. Maintainer wanted. And the using is now, holy F, pinpoint porter from Go. This is written in JavaScript. Let's go. 6 years ago, you know, all of this was abandoned. All of this was abandoned here. Communication sequential process to use EX6 2016 async and await. Here's Golang ping pong example. Example of ping pong. Panic dump stack. Oh, this is now the slice of this. All right. Advanced Go concurrency patterns. Concurrency, bro. Concurrency. Okay. 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 All right. All right. Okay. Good. Concurrency, bro. Concurrency. So this is a pattern. Okay. So what we're going to learn here is not. This is something exclusively to JavaScript, but how we're going to handle is now this asynchronicity in programming language, okay? And what and what concurrency means, and what is the sort of difference between parallel and async, where parallels in the computer's context is things. Several tasks that can be done at the same time per threads, right? So you have now multiple threads, and in each one of those threads there are tasks that you can pass to this and do that in the same time or at the same time. Where now concurrency is the ability to process tasks that overlaps over times. A good example of this is like when your mom calls. You're cooking, right? And then suddenly your mom calls. It's like, hey, now you listen to her, what she's saying, and also you are actually checking your mobile phone for incoming, and checking your mobile phone for an incoming message in your Gmail inbox. All right, and also take a look at that your pancake is not gonna. That your pancake is almost ready, okay? So yeah, take a look at that your pancake is be there. So your pancake doesn't overcook. So you don't overcook. So you take a look at you don't overcook your pancake, or while actually checking out the Gmail inbox. And talking to your mom and reply that whatever asking her for 1000k to reach end of the month, right? Because you have a poor financial management skills. But in any case, that's the whole point of this, right? Is to actually recognize that this is a concurrency, and this is now how we're going to write our application, especially is in JavaScript. And one of the goals of this particular course, again according to Kyle Simpson, is that understand now how you bring words when it comes to writing patterns, or when it comes to now which is something that he mentioned here, right? Exactly. So the goal here is to know, is to learn patterns and how your brain works. So there are less bugs on it. And again, by looking at how your brain works, especially in sequence in this concurrent fashion, and what are the way of how we can now deal with this concurrency, particularly in the language of JavaScript, since after all this is a single thread language, one line after another. And then we have now some features like web workers, where you can now simulate parallelism. And the idea here is that it creates new threads. It creates a process on a new threads, and then you can now pass all of this data to this thread and share among all of the different JavaScript instance engines that you are running, right? But even though this is not this is not part of the JavaScript. This is from the web platform or the server platform, right? Even though we still have to handle is this concurrency, and the way we do that is by using several tools, right? So we have now callback, which is coming from the web platform, and say, hey, this is now the way of how we're gonna make this continuations of the code, so callbacks are a continuations of the program at some point in the futures. So this is something interesting, because if, for example, you need to write is things that are dependent or time dependent data, or time dependent callbacks here, which is one after another, after another, then you have this thing nested as the pyramid of doom. This is not the problem in itself, because if what really care about is the way of how you can write your applications, you can actually do this, right? So you can eliminate the aesthetic way of doing that, right? However, the problem still remain, which is how do we know, how do we can actually keep track of all of this, particularly async operations that's going on, especially nested operations or things that happen in parallel, and then we need to somehow to respond to that. Okay, how can we now deal with that? And this is a very common pattern on UI development, which is you fire multiple things in parallel, let's say 3, and then you waiting for them to come back. You respond them, or you coordinate its response properly. You respond to those, or you respond to them as soon as possible, as a way to now do something with that, and then do that in the order, or make sure that things happen in order here. So all of these particular things that happens in our UI development, and this is one of the reasons why it all starts with the advanced Redux, and then we have to go back to the Redux. What is the end problem that Redux actually solves? And that leads us to understand not only the Redux API, and also it is design and philosophy, and it is design principle, intent, philosophy, and goals. All right, which actually that lead us is to understand that when you're writing applications, you're not only going to take care of the state of the application and how that change. You actually want to know or have some sort of mechanism that allows you to know at which state this application is. But also you need to handle with this asynchronicity, or these concurring things that can happen, these tasks that will overlap at a time. And that's why in the context of Redux, they're using now is middleware as a way to now intersect these actions in a Reduxer, and this is something useful, especially because after all, Redux wants to now make the state mutation management a top priority, state mutations maintainable as a top priority. Now we look here and say, how can we now handle these async operations, this concurrency that eventually will happen in our applications? So that actually leads us to now understand is this particular point, which is by running by running now our own example here as a way of how can we now handling is this common user scenario, and things that most of the time we will need to have is a record, okay, where in this record we need to coordinate is the response, because it can happen now at any time. So this record where we're going to store now all of this response that can happen at any time, all right? And not only that, we need to also show them or respond them properly in that particular. We need to respond them as soon as possible if you provide some sort of callback, and also show them in order, in the order that they were called. This is not a trivial thing, bro. This is not a trivial thing that we're doing here, and it might, even though that it might look like a lot of gibberish and garbage here, but at the end of the day, actually, this is how can we achieve now, at least, is this asynchronicity, right? This way of how we can now control our continuation of these programs at some point, right? Waiting for them to come back, respond as soon as possible, have the ability to track is this response somehow, and then show them in the proper order that they were called. All of this is now a pattern, okay, as a way to see what are one of the problems, especially that using callbacks in today's world is something that is problematic. It doesn't help us allow to describe in an effective way how we're gonna handle concurrency. That's why we're starting to see is the particular patterns or the particular problems of these tools, and what of the solution or non-fixes, right? Which is, first is the inversion of control. It's like, hey, because you have the first half of your program and the second half of your programs, you have now the first half of your program that is in your control, and then the second half that is not in your control. So the way we express now how the thing's going to run in how this code will run, how the continuation of the second half of this code will run, the way of how we express that in code is by using callback. So we give these portions to the callbacks, okay, where now the first half of our code is running in our control, and when we give this second half to a callback, and then when we give the second half of the callback, that's when we invert control. We give them, we put them in control, and how and it will, and how and when it will now execute the second part. And you may wonder who is now in control of that. In your particular case, is the web platform. So when we started to understand now this, or the TLDR of this, is that you have two portions of code. One of them in your control, and the second is that you delegate, and the second is something that is outside of your control when you want to run this. So the way of how you can express now this async nature, or this continuation of your program, at some point in the future is by using callbacks. So you run the first half of your code synchronous, and then you pass now the second part of your programs to a callbacks where you invert control by put them in control on when and how that code is executed in your program. And this is now the definition here of the of this inversion control. All right. So not only that inversion control also it generates some trust issue. Yeah. This trust issue is that coming, especially when you describe a particular example, that we're not going to do that because the trust that you are now expecting from this callback to do is that, hey, trigger this not too early, not too late, not too many times, especially this one, not too many times, not too few times, no loss of context, no shallow errors, and the list go on and go on. So the other problem is that they're not reasoned about this, according to Goldstein. It's like, because at the end of the day, you are writing code, all right, and you're writing code the way how your brains will program things, planning things. There is a theory here, there is a theory here that the moment that your brain and the JavaScript codes differ in how they work, that's when the bugs happen. It means that since this is not something reason about reading, right? The idea here is develop some patterns or understanding how the understanding is this pattern. Is understanding these patterns. Is that understanding these patterns? Is like understanding how your brain works by writing patterns when it comes to deal with this asynchronicity. And that is, well, some of them propose the separate callbacks, right? When you say, it's like say, hey, okay, an error function, right? So when you try something, you say, hey, let's go to run this and the second one. The question is that when this function is gonna run, and is this function now is gonna run without too many times, without guaranteeing me any errors? Can I get the value out of this in the particular order? So this particular approach doesn't work as well, you know. But again, it is what it is. The other is the error style. They say, hey, let's go to now use a one single callback, right? Instead of two callback, which to me was quite wild. Let's gonna use now one first callback, okay? One single callback, and yeah, let's gonna use one single callback, right? And so the first parameter will be now the error, okay, here, and the second parameter will be now the value here. So this is now the error first style, again, async pattern of how you can handle this asynchronicity. Is that, hey, this particular function is handle this, so let's go to pass now a callback here that allows to now when that something goes wrong, we can detect that. Otherwise is rounds that. And the other is the nested callbacks, right? So what are now the patterns that we have now here as a way to handle is this concurrency? One of them is thunks. Okay, another thing is thunks.
All right, let's talk about. There's a bunch of Yeah, sorry. We're talking about lines 5 and line 7 for the get data. This is non-local, non-sequential reasoning even. Yes, I can move through the pyramid. But what happens when I move one of those callbacks into another module of my utility? Now I've got...
Exactly. So what one of the downside of this pattern is that for simple code like this, it's not that awful. However, when you call other models, that's when things that's when things get ugly a little bit.
This non-local jump over to some other location to understand what's happening.
So, however, when you call other models, that's when things start to be confused. That's when you start to get confused. This non-local.
What happens when I move one of those callbacks into another module of my utility? Now I've got this non-local jump over to some...
Exactly. Now I got this non-local jumps through my code to understand it. Yep. You got thunks.
Instead of trillions of years or whatever. That'd be a pretty big number for the set timer. But you see here I have the nested callbacks, and I have all the problems of this is non-local, non-sequential reasoning even. Yes.
This is non-sequential. This is non-sequential reasoning, which is exactly what happened. So this is non-sequential reasoning.
Vertically, I can move through the pyramid. But what happens when I move one of those callbacks into another module of my utility? Now I've got this non... All right, let's talk about a pattern on top of callbacks. This has actually been around for a really, really long time. It way predates JavaScript. This terminology didn't even really exist in JavaScript until people started trying to adapt this notion in JavaScript, and the word is thunk. I have no idea where they came up with this word. I don't know what they were smoking. I wish I had some of it. It's a weird word. I don't even know what its origin is. But I can describe to you what a thunk is. And it's actually kind of deceptively simple what a thunk is. From a synchronous perspective, a thunk is a function that has everything already that it needs.
Exactly. So a thunk is a function that has everything ready. A thunk is a function that has everything. A thunk is a function that has everything already. So the next time you call it, you always get is that particular value.
To give you some value back. You do not.
To give you some value back.
You need to pass any arguments in. You simply call it, and it will give you a value back. Is that?
So now this is thunk, right? This is something that predates JavaScript, right? I don't know where the name come from, thunk. I don't know where they're smoking from. Honestly, I don't know where they're smoking from. Thunk. It's a subroutine used to inject a calculation into another subroutine. Damn, son. Oh my friend just got. Oh shit. Oh grab. Damn, son. Oh crap. Oh my French just got. Oh shit. Here we go. Here we go. It's something that predates JavaScript. I don't know where this function. I don't know where this comes from, or what they're smoking. What they're smoking. What they're smoking. I could have. I would like to have some of it, but thunks is just a simple idea. Okay, so that's right. So thunks.
From a synchronous perspective, a thunk is. I wish I had some of it. It's a weird word. I don't even know.
I would like to have some of it.
What its origin is. But I can describe to you what a thunk is, and it's actually kind of deceptively simple.
Mm-hmm. Exactly. But I can describe you kind of deceptively simple, right? Exactly. Put it simple, man. Put it simple. And then I handle the complexity of all of this. It's up to me. It's up to me. But I can describe you kind of deceptively. But I can describe you. But I can describe you, and it is. And it is kind of deceptively simple, right? So from the synchronous perspective, a thunk is a function that has everything. Is a function that has everything you need to get a value back. Okay?
What a thunk is. From a synchronous perspective, a thunk is a function that has everything already that it needs to do to.
Okay. So a thunk is a function that has everything that it needs to do, so you can get a value back.
To give you some value back. You do.
And it gives you a value back. Okay, and it gives you a value back. Yeah, from the synchronous perspective, a thunk is a function that has everything that it needs to do, and it gives you a value back, right?
Not need to pass any arguments in. You simply call it, and it will give you a value back. Does that sound familiar?
So you don't pass, except you don't pass any interest. So you don't pass any argument. You just call it and get a. Exactly. You don't pass any argument. You just call it and get a value back. Right? Get a value back. Exactly. This is not from the synchronous perspective.
Remember how we were talking about that before in a different workshop? So a thunk is just a function with some closured state keeping track of some value or values, and it gives you those things back whenever you call the function. Here's a.
So to be more specific about the language, so a thunk is just a closure that keeps the state of some sort of value, and it gives you back, and it gives you back whenever you call it.
Asynchronous function with some closured state keeping track of some value or values, and it gives you those things back whenever you call the function. A thunk is just a function with some closured state keeping track of some value.
A thunk is just a closure state. It's just a closure state. A closure is just a closure state that keep tracks. A thunk is just a closure state that keeps tracks of a value
Or values, and it gives you those things back whenever.
So a thunk is just a closure state that keeps tracks of value or values, and it gives you back whenever you call it. So what you're doing is just encapsulating this particular state in a closure to keep track the state, or to keep track of the values or the values whenever you call it. So it's like a token.
Here's a synchronous thunk. I've got an add function which expects an x and a y, and I make a thunk that calls the add function and already has the 10 and the 15 in it. It's hard coded in this case. So every time I call, like I do on line,
so this
that's
is
line 6
not
to call the add
an
function. So every time I call line 9,
here.
if I call thunk over and over and over again, I'm going to get the same value out every single time. So now, here's the important part. Thunk itself, that value which is a function, it has become a container around that particular collection of state.
So thunks becomes a container of a particular state around. So thunks becomes a container of a particular state. Like this is like him.
And that is now a container that I can pass around anywhere in my program as a container wrapped around that state. And anytime I want to extract it, I simply have to call that function and I get the value out.
So thunks becomes a container of a particular state. So if I need it at any time in my program, if I need it at any time in my program, I just simple call it. Damn, so you are now, the coupling is the time for your code. Oh shit. So thus becomes a container of a particular state, and if I need it at any time in my programs, I just simple calls it. Alright, so you translate that to real life. It's like this is now a container that keep this state, all right, and any time that I calls it, I get the value out of this, or the values, I get the value for this. A container. So this container here, okay, so it says a container. So let's say you put things here, in any time you want to, and any time at some point in the future you want that, you just take a look at this and to get the value of that. And you can also keep track of that. Thunk.
I don't have to pass the value or the state itself. I pass the wrapper around that state all around my program. So it becomes like a token that represents this value, and it's easy to get it out. All I have to do is execute it to get the value out.
So it is a wrapper. It is a wrapper around this function, and any time that I calls it
itself, I pass the wrapper around that state all around my program. So it becomes like a token that
So it wraps around this function, and anytime I calls it, it wraps. It is a wrapper around this function, and any time that I call it, I can get the value back. So it represents a token, bro. So it represents a token.
Presents this value, and it's easy to get it out. All I have to do is execute it to get the value out. You may not realize it yet, but that is the fundamental conceptual underpinning for what a promise is. A wrapper around a value.
This is the fundamental concept about promises. A wrapper, holy shit, a wrapper around a value, bro. Shit. So you're wrapping this using its closures to keep the state of that values or values. Anytime you call it, you get the value. Except anytime you call it, you just simply call it. So this represents now a token. So this represents now a value. So this represents now this represents now is the completion of something, and this represents now a token about this represents now a token of this value. This represents now a token of this value, a wrapper around a value.
Here, the wrapper is a function and promises it's a much more sophisticated thing. But it's actually quite powerful to think a wrapper around a value. Here, the wrapper is a function and promises it's a much more sophisticated thing.
Here, the function is just a wrapper. Promise is just more a sophisticated. Promise is just more sophisticated.
It's actually quite powerful to think about when we extend thunks from the synchronous nature into an asynchronous nature. This is a synchronous thunk, and that's the most common definition for thunks you'll find, is that it's a synchronous thing. What is an asynchronous thunk? Well, there's no right or wrong definition here, but the most natural way that we could define an asynchronous thunk is that it is a function that doesn't need any arguments passed to it to do its job, except you need to pass it a callback so that you can get the value out. It fakes some asynchronicity with a set timeout.
Exact. Now, from the asynchronous perspective, a thunk. Okay. Now from the now from the asynchronous perspective, a thunk is a function that got everything it needs to do. That got everything it needs, except that we pass a callback to get the value out of it. To get the value out of it. To get the value out of it. From the asynchronous perspective, a thunk is a function that got everything that it needs except we pass a callback to get the value out of that. Holy crap.
Takes the callback that you've passed in on line 1, on line 3 it calls it with the addition. So we make our thunk on line 7 with add async, and we hard code 10, 15 in CD. And on line 11, we have that value, that thunk value, that we can pass around our function. And every time we call thunk and pass in a callback, we know we're going to get our value out. But here's what's incredibly powerful about this pattern. From the outside world, we do not know, nor do we have to care, whether that value is available immediately or whether it's going to take a while to get us that value.
So the powerful thing of this is that from the outside world, we don't need to care about when that value is returned.
We do not know, nor do we have to care, whether that value...
Exactly. We do not know. Exactly. We do not know, or nor do we have to care about when that value is returned.
Value is available immediately or whether it's going to take a while to get us that value.
When the value is returned, which is something that when we actually create our callbacks in a particular way to actually that it doesn't trigger too many times, too few times, not too often, without losing the context, without swapping errors. So now with this particular pattern, now we don't need to know or nor care about when this data came from, because because we have now is closure, because now it's them. So because now we have a closure state that keep track. Because we have now a closure state that keep tracks now is when this function, because we have now a closure state that keep tracks the execution of these functions, or because we have now a closure state that keep track of value and values, and anytime we call them, we get it back. Okay. This is quite interesting about the pattern, bro. It's like this particular patterns allow us is to don't need to reinvent the wheel. But we need to understand why we don't need to reinvent the wheel. Oh, great.
What difference does it make to us? We pass in a callback. We know you'll call the callback when you have a value ready for us. So the first time we call thunk and we pass in a callback, it might have to do some significant work to calculate the answer to our question. It might make some AJAX call and do some other kind of crazy calculations, and it might take a while. And then it may decide to memorize the answer to that question, so that the next time you call it, it just gives you the value back right away. But from the outside world, does it matter to us whatsoever how that works? Calculate the answer to our question. It might make some AJAX call and do some other kind of crazy calculations, and it might take a while. And then it may decide to memorize the answer to that question, so that the next time you call it, it just gives you the value back right away. But from the outside world, does it matter to us whatsoever how that works? What's happening here is that by wrapping this function around the state and allowing it to be asynchronous in nature, we have essentially normalized time out of the equation. We have factored time out of the equation. We have produced a wrapper around the value that has become time independent.
We have produced a wrapper around a value that has become time independent. Because now is a closure here is now capable of keep track of that state, and at some point in the future, all right, when the value is getting back, now you're going to get that through the callback using its closures, using is now this function that JavaScript using that this feature that JavaScript provides to you to store informations, to store things, to store now lexical scope out of this. This is now a way of using this particular tool. This is now how you can take a look at how you can use it to do that. Oh my God, to actually tackle a particular problem with this. Hey, this is the tool that we have. How can we use that That's what you need to be in the present, especially when you're using your tools. So now this closure here that return is now is the lexical scope around a function, and then it stores that, and then it stores that, and then it stores that closure, right? And then it stores that here, right? And then it stores that, okay? And then it stores that a function is creating and a function creation time. In JavaScript, closures are created every time a function is created. Interesting. So every time a function is created, at function creation time. So it create now this closure. Exactly. It create now this closure at every time a function is created. So every time a function is created, by creating as a function execution context, it create this closure. It create now this bundling or combination between the reference to the surrounding states. To its surrounding states, right? So the more functions you define here, and each one of them has some states, so you can now have access to all of these previous state. You can have access to all of this outer reference, out of the local. You can have access to all of this you can have access to all of this outer lexical scope here. Scoping with let and cons. ES6 introduced this. So a closure is created is that anytime a function is created, right? So running this code has exactly the same effect as the example of previous. What's the difference and interesting is that display name inner function is returned from the outer function before being executed. At a first glance, it might seem unintuitive that this code still works. In some programming language, the local variables within a function exist for just the duration of the function execution. Once make thunk finish executing, you might expect that the name variable will no longer be accessible in this case. However, because the code still works as expected, this is obviously not the case in JavaScript. The reason is that functions in JavaScript form closures. A closure is a combination of a function and the lexical scope within that function was declared. This environment consists any variable that were in scope in at the time the closure was created. In this case, my function is a reference, like that. So my function is a reference to the instance of the function displayed name. My function here is just a reference to the instance of the displayed name. It's a reference of that instance that is created when make function is run. The instance of display name maintains a reference to its lexical environment with which the variable name exists. For this reason, when my thunk is invoked, the variable name remains available for use, and Mozilla is passed to console log. Here's a slightly more interesting example at add make adder. So the thing here is that now you have is a reference to that function. So my function here has a reference to the display name as it is. So this is the way of how you can read about it. It's like when you're looking at this and you're returning is this, you say, hey, now the time that I call in this function is just only a reference to that function here, right? And this function here, because now anytime you define or create a function, it has a closure. And a closure I have is the ability to allow you to access to the outer scope from the inner scope. This is something that JavaScript does. The question is that other language does that does that s does that it's because it's called a reference here. So the maintains a reference here. In this example, we have defined the function makeAttr here, right? So you say, hey, I'm going to return now this reference of these functions here, and by the time you create this function, I'm creating is a closure. Okay. Make the adder and function here. The add 5 and add 10. So make adder here. It say, hey, I'm now going to call this reference of this function here. All right. That you're passing me with some value. All right. Similar for this, I'm going to create now this function. I'm going to create a new function execution for this and for that. Each one of those function executions now pointing to another function execution, which is in this case here. All right. And because of that, by the time that I now run this reference with this value, now they're going to actually is called them. It's gonna call that. It's gonna call that function with that reference. Jesus fucking Christ! It's gonna call now this function with that reference that we store in memory. Okay, hey, we're calling. This is the definition here that we store with all of this setup stuff, right? And we have it. And by the time we run now that variable that have a reference to that function, okay, now we're going to run whatever it has in that particular state with this new state, with this new data that we're gonna pass to. Jesus fucking Christ, bro. In essence, makeAttr is a function factory, because now this is just generating reference of these functions, right? It's creating reference of these functions. It creates functions that carry specific values to their argument. This is a particularly interesting pattern here. You are now creating function with this reference. You're not creating is a set of you are creating now a set of predefined instructions here. Jesus. So you're now creating is a predefined set of instructions anytime you call that. All right. And if you want this to now is change those set of instructions or change the output returning by that, you just is pass another one. But this is something interesting. This factory functions is just returning is a set of instruction, okay, anytime, but it's returning is a set of instructions. Returning the it's returning is the same set of instructions here. Jesus, okay. Practical closure. Closure are useful because they allow you associate data, the lexical environment, with a function that operates on that data. Because after all, you have now this set of instructions and this data bound together. This has obvious parallels to object-oriented programming. With objects are associated data and it is functionality and it is methods. At the end of the day, object-oriented programming is about grouping its data and its functionality together in the same bundle. So a closure is doing that by bundling is this function reference or this set of instructions with this data. Oh my god, in this data or this state. So why this is useful? So because now we have this ability to have a reference of these methods, and it is data have this reference of this. We can now use that as a way to represent things here. And the thing that we can use to represent is, for example, is thunks. For example, is promise. This data and this method here. Okay, data and object modeling, representations. Consecutively, you can use a closure any way that you might normally use an object with only a single method. Situation where you might want to do this are particularly common on the web. Much of the code written in front-end JavaScript is event-based. Exactly. You wait for something to happen. You define some behaviors and then attach to it an event that is triggered by the user. So you have now these methods here and the state here. So by the time those methods are called, okay, then you can now update the data properly. The code is attached as a callback, a single function that is executed in response to the event. For instance, like this, such interactive text side button, you say, hey, let me now define is this function here, this object, this function objects, that now is going to have a reference of the data as well as the functionality of this. Oh my god, but this is again, oh shit, this is now a way of how the creator of JavaScript say, hey, you know what, let me do this in 7 days that is resemble to Java. All right. Oh shit. That is resemble to Java when you have now the data and the functionality in a single bundle, because it's made much more easy to read, reason, and maintain. Okay, and with this things that is from Lisp. All right, that is Lisp. That is. That is Lisp things of doing things. Holy shit. So the Lisp is this now way of how you can process Lisp. And the functional programming. So now, of course, what you're doing is just having is a reference of these different states that you want to keep track of it. Exactly. So you are now holding this reference of these different states that you want to keep track of this. Exactly. And then by the time you say, hey, so let me now attach this callback here. By the time you actually click on each one of them. So by the time you do this, which is, oh, they updated that? That's interesting. That's lovely. So by the time you have is this, right? You define some paragraphs here, that kind of thing. Some paragraph and that kind of thing. So by the time here, you define is this, and you say, hey, because now we are globally access to this document with font size. Okay. This is something that you want to avoid that. I prefer to actually is now pass is a document here as a way to get that as a reference. All right. And here you say, hey, let me actually send you the document here, which will be much more easy to read that, right? So we save us a lot of time here. Document, All right. Remember that at the end of the day, what the fuck? Oh, that's right. So remember that at the end of the day, we want is, since in JavaScript we can have access to several global objects, whether it is a window or document. Okay, this is the most common, and the document allows you to now have access to this DOM node to interact with the DOM. And by the time we get this, we say, hey, let me now create this reference of this instructions or this functionality here and attach this data to this. So here I effectively are creating is some sort of object programming class object, okay? Pretty much like you say, hey, class, because behind the scene is using now this function constructor. You say, hey, make sizer, okay? And instead of passing these parameters, this is the way of how you pass this parameter using a construction that you say, yeah, the size and the document here, okay? This is one of the data that you want to get access to, all right? And if you want to make them available through all of this set of instructions, in this case, this object, you define now that you say, hey, size, okay, you say public, let's make this public, and let's make this public document, all right, public size here, that I don't know what is the size, it is 0, let's see initially, and public size here, no. I don't know how you can define a class here. Okay. Oh, interesting. Interesting. Okay. This is now okay. This is now how you define this in JavaScript. This dot size. All right. Then you say the size, and this dot document makes a lot of sense because behind the scene is using now the new keyword as a way to actually run this. Okay. And then you say, all right, now let me define the functionalities here, right? Let me define the functionality here, which is instead of doing this, you define the functionality here, and then you say is now, say called class size, right? When now you define the functionality here, that of course you want is now the that in this case make sizers, you want is to accept is now yeah, that right. You wanna know is return is the make sizer here. And this make sizer, which now contains all the data that it needs to. Then you say, okay, now that I have access to this document, okay, from this bundle of data, let me actually access to the body and the style, and then change the font size here, to this dot size plus pixel, right? So what I'm doing here is just prefixing this. So instead of doing this, we use is now this size using the new keyword, right? And now call that, assign this method here, this make sizer here, right? So you may wonder what we did here. Well, it's just actually is triggering is that, right? It's actually working as expected. It's now 12, and this is actually 12. So that's what happened. If you pass this, if you say this, you eventually you say no. Of course, it won't work because you need to pass is a reference. This is a callback here that you're passing. That's what happened. So this is a very silly example here, but a very interesting in terms of how now JavaScript objects work, especially with functions, as a way to encapsulate its data and its functionality, and how closures bring this these features to the language. All right. And this is something useful, especially as a way to have a token of this functionality, of this set of instructions that are tied to a data. Language such as Java allow you to declare method as private, meaning that they can be called only by other methods in the same class. JavaScript prior to classes didn't have a native way to declare in private method, but you can possibly emulate that by putting in something like private things like so, right? How closure to use the define public function can have to private method. In previous example, each closure has its own lexical environment. Here, though, there is a single lexical environment that is shared by the three functions. Exactly, which is private counter. In each one of them, now they have a reference of this set of instructions for that, right? So by the time you call now the counter here, which is immediately invoke function expression, it say, hey, let me now run this function and then return you a reference of this set of instructions here. Dot value, and then when you call that now counter dot increment, okay, it will now increment that change by and change by increment route. The counter value is 2, and then decrement, the counter value is now 1. The lexical environment contains two private items, a variable called private counter and a function called change by. You can access either of these private member from outside of anonymous function here. Exactly, you can access either of these private methods to that exact. So for example, change by, because they were already executed and you just only hold a reference of those functions that it is exposed. So you can have access to change by for that. And the closure scope change. Very, very interesting. So, okay, this is now as a way to understand how your tool works, bro. This is now as a way to understand how your tool works, bro.
It doesn't matter if the value is there now or if it's going to come later. We still use it in exactly the same way.
And if the
Hear this.
context here with thunks, which is now we have everything, which is from the synchronous perspective, is a function that has everything that it needs to do. It's a function that get everything that it needs to do, and whatever you call it, you get the value of that. So this is something interesting because you can think of this as a container, as a token of this state, because this thunks is now have the ability to keep track the state and the functionality. In this case, the state. He has the ability to keep track of his state. So this function has now the ability to keep track of his state. Interesting. So this function now has the ability to keep track of the state. Yeah, now this function have the ability to keep track is the state and act as a token, as a container, and whenever you need that value out of that, you just simply call it. When with the asynchronous is that it's pretty much like an asynchronous function, like an asynchronous thunks, which is a wrapper around a value, which is a function that has everything that it needs, which is a function that has everything that which is a wrapper that a function has everything that it needs to do, and you can call that whenever you need that to get the value out of that. And in the context of asynchronous is this is a function that has everything that it needs to, except you pass now a callback. So by the time you except that you pass now the callbacks, that you can get the value out of this or values of this. So the thing here is that now it has the ability to keep track the state of this.
You don't hear anything else that I've said
And it's because thanks to closure.
Today, time is the most complex factor of state in your program. Managing time is the most complex state in your program. That's why this is huge, to be able to come up with a very simple, there's no libraries involved, this is straight up core JavaScript, just a different way of looking at and using the mechanisms that have been available to us for all 20 years. We've taken this notion, this fundamentally difficult thing to reason about called time, and we've eliminated it as a confusing factor, as a complicating factor. I have this thunk.
So this is huge because we have eliminated this complex stuff called time out of the equation. Yeah, we removed the time out of the equation to deal with
this fundamentally difficult thing to reason about called time, and we've eliminated it as a confusing factor, as a complicating factor.
Especially when we need to actually reason about is when the time is, when this response gonna get arrive. So this is huge because we have eliminated this complex stuff called time out of the equations when it comes to deal with asynchronous data and how the asynchronous data. Exactly, and if you remember, for example, from previous exercise, that this is how the way you do these kind of things, as a way to actually see how you can now manage all of this parallel requests, and then you need to know, you need to wait for them to come back. That can be at some point in futures. So that's why we create this particular table here as a way to add them as they come here, and then responding as they come here, right? And then show them in order. So this is huge because we have eliminated this complex stuff called time out of the equation when it comes to deal with asynchronous data.
Fact. I have this thunk. It represents a value. I pass it around whenever I want the value.
So I have these thunks. Exactly. I have these thunks that represent a value, and whenever I need it, yep, I have this thunk that represents a value, and whenever I need it in my program, and whenever I need the value, in my program, okay? So I have these thunks that represent the value, and whenever I need exactly, and whenever I need it in my program, I just simply call it.
I give it a callback and I get the value out, and that's all I have to do.
In this case of the asynchronous, exactly. In the case of the asynchronous, I have this thunk that represents a value, and whatever I need in my program, I just simple pass a callback to get the value of. That's what the thunk is all about, especially in handling asynchronous operation. Is that, hey, I create this wrapper around this set of instruction, and by the time exactly creates this wrapper around this set of instructions, that by the time they now receive that data, I just, as a way to get that value out of this, I just pass is this callback here. I don't know what the smoking,
I can tell from your faces that you're not realizing how
my holy hell, I know what the smoking.
But that is one of the most important observations. I couldn't believe when I recognized
fucking
what that meant. I could
God.
not believe how far I had gotten in JavaScript.
How the French toast? Oh shit, I couldn't believe how I was writing a lot of crappy code in JavaScript without understanding this.
Without that realization.
Oh, yes.
It changed everything for me.
Yeah,
and
of course.
Fact, it's what helped me understand promises. I didn't fully understand the conceptual basis for promises until I understood what thunks were doing. Because we'll find out that a promise is a time-independent wrapper around
It's a time-independent
wrapper.
wrapper.
Just has a fancier API. So
but this is not a time-dependent. This is a function execution. It's a time-independent. It's a time-dependent value, whether it's synchronous or asynchronous, because it acts as a token. This is a wrapper around a function that has everything that it needs to do, and you just have everything that it needs to, and then you get and wherever you need the value, you just simply calls it. In the case of the synchronous function. In the case of asynchronous is, hey, this is a function that has everything that it needs to. This is a function that had everything that it needs to. And by the time I need this value, I just simply pause a callback to get the value out of this.
Okay. Now,
this representation, this token representation, is something that allows us to now use the synchronous nature.
there are some twists, there are some wrinkles that we can throw into the situation. If I wanted to make a thunk, give myself a generalized utility for making thunks, I can do all that old crappy array stuff and pushing the arguments on. Now, there are some twists, there are some wrinkles that we can throw into the situation. If I wanted to make a thunk, give myself a generalized utility, there are some twists, there are some wrinkles that we can throw into the situation. If I wanted to make a thunk, make API. Okay. Now, there are some twists, there are some wrinkles that we can throw into the situation.
Wrinkles. What the hell is wrinkles? Okay. There's some wrinkles. Okay. However, there are some twists, some wrinkles. Okay then. Around this. For example, if you want to create a general utility, you know, oh my
Now,
god.
there are some twists, there are some wrinkles that we can throw into the situation.
For example, okay. However, there are some twists, some wrinkles that you can throw to this situation. For example,
if I wanted to make a thunk, give myself a generalized utility.
If you want to create a generalized utility, this is when the algebra kicks in. Algebra stands for generalizations. I mean, the etymology of this. In the Old French, formal mathematics, the analysis of equations, the art of reasoning about quantitative relationship by the aid of compact and highly systemized notation. God damn. It's all about generalizations. It's generalizations. Al-Arabic, in vulgar pronunciation, algebra, reunion of broken parts. Reducing fraction to integers in computation. Reunion of broken parts. Al-Warismi book, reintegrate, reunite, consolidate, calls the works Al-Jierber and Al-Machabel. Reunion of broken parts, or trying to make it again. So it's different perspective here. Reunion of broken parts, algebra, or making generalizations. Okay. Holy crap.
For making thunks. I can do all that old crappy array stuff and pushing the arguments on and calling apply. I could do it that way. And I could use it this way, as we see on line 7. Array stuff and pushing the arguments on and calling apply. I could do it that way. And I could use it this way. If I wanted to make a thunk, give myself a generalized utility for making thunks, I can do all that old crappy array stuff and pushing the arguments on and calling apply. I could do it that way. And I could use it this way, as we see on line 7. So now I'm not manually making one, but I can make any thunk that I want by presetting the callback as the first argument, and anything else that I pass, it's going to get passed along to it always. And that's how I can produce my thunk. So I can make myself a utility for making these, which would be not fundamentally terribly different from a promise.
Because at the end of the day, this is where you can have access to this. So function they have now is default parameters, exactly. The argument object. Mm-hmm. Static method and properties. You have now arguments. Length, name, borderline, right? But again, this is now. Mm-hmm. The arguments object. Oh, of course, of course. Okay, because this is instance. Okay. Static properties. An instance property. Through the arguments, exactly. Mm-hmm. Exactly. So this is now global variables that you can have access to this. So
Make thunk would be kind of like a promise constructor. It's a constructor for passed along.
Where you say, hey, whatever whatever function that I make here, okay, as a way to make this as a function, because after all, this is a wrapper around a function. Okay, because I want to return now a reference of these functions that will now is contains is this callback that I'm passing here. I'm not only going to pass the as a way to now make this make these thumbs here. So I'm now going to hold is a collections of callbacks. All right. Exactly. Not only gonna have is a collections of callbacks here. That'll be part of this function, thunks. But also after that, I'm going to call that with all of these arguments, with all of this callback here.
I can do all that old crappy array stuff and pushing the arguments on and calling apply. I could do it that way. And I could use it this way, as we see on line 7. So now I'm not manual.
So yeah, you see it's like, hey, because now I'm making thunk of these functions and the parameters. So behind this thing is now creating is a closure or this function reference that is say, hey, let me now store all of this data. Let me now store all of these arguments here. Okay. And by the time that you call this thunk, you're gonna not only call this, you're gonna call is this function here, or previously it say, hey, you're gonna now attach all of, you're gonna attach now this callback to this function with this arguments. You're gonna attach now this callback to this function and arguments. We should say is like you're gonna now attach all of these callbacks to this function and argument
stuff and pushing the arguments on and calling apply. I could do it that way. And I could use it this way, as we see on line 7. So now I'm not manually making one, but I can make any thunk that I want by presetting the callback as the first argument, and anything else that I pass, it's going to get passed along to it always. And that's how I can produce my thunk. So I can make myself a utility for making these, which would be not fundamentally terribly.
Which is now by the time I create the thunk, this independent wrapper of this, by saying it's like, hey, I can now pass all of these arguments here, keep track of those arguments, that those arguments will be now is those callbacks. Okay.
different from a promise constructor. Make thunk would be kind of like a promise constructor. It's a constructor for thunks. Yes?
Could you go through the, so when we talked about the problems of callbacks, this inversion of control, not too early, not too late, not too many times, and just expound a little bit on that with how the promise thunk is.
We're actually not gonna have any solution to inversion of control with thunks.
Yeah, okay.
Promises are gonna solve inversion of control. We're not quite there.
Yeah, okay, that makes me more...
Yeah, we haven't solved inversion of control yet. We're laying the conceptual underpinning for promises, and that's why we're looking at that.
Yeah, I just wanted to, because that realization happened earlier. We're like, now getting a better understanding of what promises are.
Yep.
And just wasn't sure how much the fancy API is, solving our problems, or how much is the thunk solving.
Yeah, got it. The thunks really aren't addressing inversion of control. The nature of how promises are designed to solve that, so we'll get there. Okay. There's a question about going over slide 39 again. This is a synchronous thunk. As you can see, I have an add function that receives an x and a y, and I make another function called thunk, which doesn't need any arguments at all. Thunk can simply be called because it is hard-coded to know to call the add function on line 6, and it's hard-coded to know to pass in the values 10 and 15 also on line 6. So everywhere we do something like we do on line 9, we're going to get the exact same value out. That's a synchronous thunk. Slide 40, the asynchronous version. Exactly the same concept, except we need to pass in a callback to our thunk. So line 11, I can't just call thunk and get the value as a return value. I have to call thunk and give it a callback, which will receive that value as I do on line 11. You're going to get a chance to practice with thunks, I promise. All right, so here's a rewriting of that silly running example, calculating the meaning of life, but using thunks. Now you notice something slightly different from what I did before. On lines 1 and 2, I pre-create some thunks. I say that get10 needs to, when it's invoked, call getData with the value 10. So line 1 has not actually made that AJAX request yet. That's important to understand. All we've done is create a wrapper that when called will do that AJAX
when
request.
called, exactly.
So I've pre-set up the get10 and the get30 thunks.
So what it's doing
and I
is
can
just
start using them. So line 4 I use it, call get10, give it a callback. I know 1,000 milliseconds from now, num1 will have the value 10. Then I use the get30 thunk on line 6. Now you notice on line 9, I create another thunk. Why couldn't I create that thunk, the one from line 9, why couldn't I pre-create that up on line 3?
What?
Thunk. I know 1,000, pre-set up the get10 and the get30 thunks, and I can start using them. So on line 4, I use it, call get10, give it a callback. I know 1,000 milliseconds from now, num1 will have the value 10. Then I use the get30 thunk on line 6. Now you notice on line 9, I create another thunk. Why couldn't I create that thunk, the one from line 9, why couldn't I pre-create that up on line 3? Now you notice on line 9, I create another thunk. Why couldn't I create that thunk, the one from line 9, why couldn't I pre-create that up on line 3?
Because they are depend. Okay. Because now they are time dependent, man. Because now they are time dependent.
Because it's temporarily dependent upon the responses from the first two thunks.
They're time
Everybody see that?
dependent.
So that's why I had to defer the creation of that particular thunk. But on line 13, I can simply call getAnswer, which is my thunk, and I will retrieve it. That now getAnswer happens to be a container around that value, and I can pass getAnswer all over my program, and anybody that needs the meaning of life can simply call that, give it a callback, and get the answer back. Now there's something really important to note here. As I said, it's important to note that this particular expression of a thunk is what I guess I would call a lazy thunk, if I was really trying to come up with some terminology for it. It's a lazy thunk in that it doesn't do the work until you call it the first time. You could make an active thunk, which did the work and just held on to its response. So it did the work right away and held on to the response. That is another way of doing a thunk. And I'm giving you a gigantic hint for your upcoming exercise.
Is it like deferring a promise or something?
It's a lot like a promise. That's why I'm saying these are the conceptual underpinnings. So our current expression of thunks is very late.
So the following is how we can create is a time independent or a time dependent code using thunks. God damn it. Holy moly, bro. Oh crap. What I have done. Where did I get in here?
Easy. It is possible to do thunks in a different way, which they are active. That means the first time they're called, the first time they're set up, they do the work, and they don't give you the answer until you pass in the callback.
Holy
Exercise 2.
crap. Okay, so that'll be all for this video. Take care. Bye bye.